Hello there, this is Miss Nakayama, and today's lesson is 7.1, Systems of Linear Equations in Two Variables. So you've done this before. Just to refresh your memory, though, what we're going to talk about in this video, we're going to, first and foremost, decide whether an ordered pair is a solution of a linear system. We're going to solve linear systems by substitution. We're going to solve linear systems by addition. We are going to identify systems that do not have exactly one ordered pair. And then last but not least, we're going to solve word problems and using linear systems. Okay, to make sure you know, why is it called a linear system? Okay, anytime you have two equations, a system of linear equations, or a linear system, it is sometimes referred to, is when you have two or more equations whose graph is a line. Okay, so you're familiar with ax plus by equals c, could be y equals mx plus b, it could be anything. The point of it is when you graph it, it's a line. That's why it's called a linear system. Okay, and the solution to that linear system is any ordered pair that satisfies both equations in the system. If it has at least one solution, it's called consistent, and if it has no solution, then it's referred to as inconsistent. So let's get started. I would encourage you to watch me do the example and then pause the video and then copy it down. Might help it go faster, but make sure that you're following what's going on. So first and foremost, determine whether an ordered pair is a solution of a system. Okay, we just said, if it is, it has to satisfy both equations. So those are both of my equations. 2x minus 3y equals -4. 2x plus y equals 4. And I'm going to plug in 1 for x and 2 for y. So 1 for x and 2 for y. This one checks. 2 minus 6 is -4. Plug in 1 for x and 2 for y. 2 plus 2 is equal to 4. So that checks. So that is a solution to the system. Okay, doing the same thing with the next one. Okay, plug in 7 for x and 6 for y. 14 minus 18 is -4. 7 for x and 6 for y. 14 plus 6 is 20. That is not 4, so this is not a solution. Okay, now on this next screen, y'all, these are the steps to solving by substitution. Pause it, copy it down if you need to. You do not have to copy it down because I know that y'all know how to do this. So again, watch me do the example so you can make sure you understand it, and then you can pause the video and copy it down. Now, the other thing to keep in mind is you have to follow directions on these problems. So if it says solve by substitution, you must solve it by substitution when you're doing the problems on your lesson checks. So when you do it by substitution, the easiest way is to look at your system and to find a variable whose coefficient is 1. So this y right here has a coefficient of 1. So the easiest way to start is to solve that second equation for y. When you do, subtract 2x, and so you're going to get that y equals 1 minus 2x. And if you want to write -2x plus 1, that's fine. And then I'm going to take that and I'm going to go plug it into y into the other equation. Okay, don't plug it into itself. So I'm going to the other equation, 3x plus 2, and I encourage you to put parentheses around it, y'all. It just makes it easy to follow your work. So I put parentheses around the variable, or instead of the variable, I put parentheses because I'm going to substitute. And what am I going to substitute? 1 minus 2x. Then I'm going to distribute, and I'm going to simplify the terms and find out that x equals -2. And when I do find x equal to -2, then I'm going to go plug it into that equation that I have solved for y, which is right there. So that's where I'm going to plug it in, okay? And when I do, that's going to give me, where am I? 1 minus 2 times, again, instead of my variable, I put parentheses. And what am I going to put in that parentheses? I'm going to put -2 because that's what we just found. So y is equal to 5. And as I also stated, every answer, these are linear systems and two lines intersect in a point. So I'm going to write my ordered pair as a solution. Okay, if you wish to check it, You know how to check it. Plug it back in, -2 for x, 5 for y, and you'll see that -6 plus 10 is equal to 4. So this checks. And you might wonder, why did you not check it into both? Well, I plugged it into this bottom equation to get the other number. So obviously it's going to check into that one. So that's why you really only have to, check it into one of the equations. Okay? All right, our second method, they refer to it as addition, but you know it as elimination. Again, here are the directions. I don't think y'all need to write them down, but if you want to, you can. But here is one that you have to solve by the addition method. Okay, addition, y'all know it as elimination because we're going to add the equations together, or subtract if you wish to think that. Add the equations together to eliminate a variable. So when you look at your system, 4x plus 5y equals 3, 2x minus 3y equals 7. I don't have anything that has just a coefficient of 1. So this is an example of one that it is better to use the addition method. So look at your variables and see if any of them is a multiple of another. Well, 2 goes into 4, so it's going to be easier to make my x's fall out. So I'm going to keep my top equation the same, but I'm going to multiply this bottom equation. And y'all, when you add them together, they need to be opposites. So I'm not going to multiply it by 2. I'm going to multiply it by -2. So when I multiply by -2, I'm going to get -4x plus 6y equals -14. And then I'm going to add those two together. And when I do, my x's fall out because I got 4x minus 4x. That goes away. And that gives me 11y equal to -11. I'm going to divide, and I have y is equal to -1. Now, at this point, you can go back to either equation. It does not matter, okay? I happen to choose the bottom one, so I'm going to plug in, and I'm going to put parentheses in for what I'm substituting instead of the variable. So I'm going to put a -1 in for y. And when I simplify that, 2x plus 3 equals 7, subtract your 3 and divide by 2, and x equals 2. Again, the answer is an ordered pair. So my answer is going to be 2, -1. Okay? Again, if you want to check it, okay, I checked it into the bottom one. So when I actually go and check, I really only have to check the top one. So I'm going to plug in 2 for x, -1 for y, and 8 minus 5 is equal to 3. So I know I'm good. All right. A quick visual. Okay, we've been talking about this, but you should know exactly one ordered pair, one solution looks like this when you look at it. It's two lines that intersect. If there is no solution, then the lines are parallel, and infinitely many solutions mean the lines coincide, or one is what we call dependent on the other. Why? Okay, I'm so sorry. All right, so let's look at these two examples real quickly. So example 4, solve this system. So when I solve it, y'all, okay, I got 5x minus 2y equals 4, -10x plus 4y equals 7. It doesn't matter which one. I'm just going with the x's. And so I'm going to take that top equation and I'm going to multiply it by 2. And when I do, I'm going to get 10x, and I'm going to get minus 4y is equal to 8. And when I add those together, my x is -10x, and 10x is 0. 4y minus 4y is 0. And 7 plus 8 is 15. Okay, so that's what it looks like. That, of course, is not a true statement. Okay, that's a false statement. And when it's a false statement, your answer is no solution. So it's important to understand what happens when you're solving it algebraically and things don't quite work out. So look at this guy. In this particular one, x equals 4y minus 8, 5x minus 20y equals 40. One thing I didn't mention, y'all, but whenever you're doing elimination, it is easiest if you have, make sure things are lined up. Okay, it doesn't matter if x and y are on the same side. You could have the y's over here, but you need to have them on the same side of the equation. Okay, so in this particular one, because I've already got something solved for x, I'm actually just going to go take this thing right here and I'm going to plug it in for x. So, using my parentheses, I'm going to put 4y minus 8 in for x, and I'm going to simplify. That's going to give me 20y minus 40 minus 20y equals negative 40. My 20y's cancel out but equal 0, so I end up with negative 40 equal negative 40, which is a true statement. So this is the proper way to write it. You've never written it that way before. You've probably always just answered the question and said infinitely many solutions. Well, they told you to solve. They don't want to know how many, they want to know what they are. So this is how we write it in pre-calculus and beyond. Okay, it's the set of ordered pairs x, y, and that vertical line means such that. So this says ordered pairs x, y such that it satisfies that equation. So any number you put in that works for here is going to work for that system. And of course, because the two equations are basically the same, in our picture there one is on top of the other, then the other way of writing it is to say you can choose the other equation. It does not matter which one. And you'll see both of those in my lab math. All right, let's do some word problems real quick. Okay, I'll work on figuring out why that's happening, y'all. So mixtures. All right, so this equation for mixture, y'all keep in mind there are multiple ways. I'm trying to come down. That's too high. There are multiple ways of solving these problems. I was given an equation, and this thing has stuck with me over time, so it's the one I like to use. And I promise you, I struggled with word problems in high school. But the equation that I have was given goes like this. It is a percent times a quantity plus a percent times a quantity equals a percent times a quantity. So it's the same thing, but these two percents, okay, two numbers, this percent here will always be in between those two numbers. Kind of a way to let you know you've set things up correctly. And it says quantity 1 and quantity 2. Those two are going to add up to be that. So this number will be in between these two percents, and this right here in parentheses is going to add up to what those are. So watch how I do this with this particular problem, mixture problem. Soybean meal is 12% protein. Cornmeal is 6% protein. How many pounds of each should be mixed together in order to get 240-pound mixture that is 8% protein? So I want to know how many of each. So your variables generally answer your question. So I'm going to let X be my soybean meal and Y be my cornmeal. Okay? So when I write my equation, okay, I'm going to do my percent times my quantity. Well, that's going to be 0.12 times X, okay, as a percent. Cornmeal is going to be 0.06Y. That's my percent times my quantity. And then my percent in between, of course, is 8%, 0.08. And my quantity is X plus Y. Now, they did tell us here that they want to get a total of 240 pounds. So that means I know that X plus Y is going to equal 240. So when I come to this next line, I'm going to be able to put in 240. You can solve this however you want. Okay, so once you get to the equations, but X plus Y is equal to 240. But I'm also going to take X plus Y equal to 240 and solve for one of the variables. I just happen to solve for Y. So that's 240 minus X. And then I'm going to take it and go plug it in for Y. So my next equation is going to look like 0.12X plus 0.06Y, but Y is 240 minus X, equals 0.08 times 240. And again, some of y'all might be able to get this equation without doing all this, and that's fine. But there still should be some type of equation to set up for this problem. Okay, so when you simplify that, you get 0.12x plus 14.4 minus 0.06x equals 19.2. Simplify things, I get 0.06 equals 4.8, and so x equals 80. Okay, x equals 80 means I'm going back up to where did I solve for y? Y was equal to 240 minus x. X is 80, so y is equal to 160. Okay, so how much of each? That means that I'm going to have 80 pounds of X, which is my 12% protein. How many pounds of each? Soybean meal, which is 12% protein, and then 160 pounds of 6% protein. Okay, last problem, finding a break-even point. Okay, a company that manufactures running shoes has a fixed cost of $300,000. Additionally, it costs $30 to produce each pair of shoes. They are sold at $80 per pair. Determine the break-even point and describe what it means. Okay, so y'all need to know what a break-even point. Okay, a break-even point in business. There are two main dollar amounts that they're always concerned about. One is the cost. How much does it cost to make everything? And one is the revenue. And your break-even point is when the cost is equal to the revenue. So my cost, how much does it cost to make the shoes? I will say determine the break-even point. And so, well, we're going to find that out, but that means I'm going to find out how many pair of shoes. And so that's what my variable is going to be. X is going to be the number of pairs of shoes. And so to start off with, my cost, often referred to as C of X, is equal to, I have a fixed cost, and that happens a lot in business. Fixed costs, y'all, are examples of renting the building. I have to rent the building no matter whether I make a pair of shoes or not. I got to pay for electricity. I got to pay for water. Those are fixed monthly costs that you have. And so they know, excuse me, that's going to be $300,000. And then it's $30 per pair of shoes. So that's 30X. That's your cost. Now my revenue is the money I bring in. And my revenue, denoted with the capital letter R of X, is $80. I get $80 for every pair of shoe I sell. So if I want to find out where the cost is equal to revenue, I'm going to set these two equations equal to each other. 80X is equal to 300,000 plus 30X. So subtract my 30X, divide by 50, and I find out that if I sell 6,000 pairs of shoes, I will break even. And that means anything more than 6,000, I'm in a profit. Anything less, I'm losing money. But I also want to know how much money that's going to give me. So I plug that into my revenue. 80 times X. X was 6,000. So my revenue was going to be 480,000. So the break-even point is the ordered pair, 6,480,000. Okay. What does that mean? That means that the company will break even if it sells 6,000 pairs of shoes, and the revenue will be 480,000. So if you have any questions about anything, please write it down. Don't hesitate to ask me. If you want me to show you something a different way, please let me know. Thank you so much for watching, and y'all have a great day.